Hey buddies, welcome into another session of the final exam preparation session. In this session, we'll be looking into analytical geometry, that is, we'll be focusing into circles. Now, if you are new to the channel, I would like to welcome you and I would like to advise you to subscribe so you won't miss when other videos gets uploaded. So without further ado, we're gonna jump straight into today's session. Now in this session, we'll be looking into analytical geometry circle. Now the statement goes as follows. In the diagram below, a circle with center M, which is 5:4, touches the y-axis at N and intersects the x-axis at A and B. PBL and SKL are tangents to the circle, where SKL is parallel to the x-axis and P and S are points on the y-axis. LM is drawn. Alright, okay, so now first thing first, this thing you need to do it on all questions that you'll be encountering, which is you need to write down the information that you're given. So here, what is it that we're given here? So we're told that we have a center of a circle, right? And then the coordinates of this center, it is M, given as 5:4. So that's the first thing that we're given. What's the second thing? The second thing, we're told that we have a y-intercept, and that y-intercept is the coordinate N. Now it is very important to understand that if we have a y-intercept, it means the x value is going to be 0. So here we have 0 is to y. What about the second point, the third point? Now the third point here, we are told that we have x-intercepts, right? We have x-intercepts. So what are those x-intercepts? It is A and B, right? A and B. Same applies. In x-intercept, we know that our y value, it is 0. So let me put 0 there. Okay, let me just give a space there, 0. And B, which is gonna be 0. So we don't know the x values here. Alright, what else? So another thing that we told here, we said PBL and SKL are tangents to the circle, right? So we have, let me write here, we have PBL and SKL as tangents, right? And also we're told that SKL is parallel to the x-axis. SKL parallel to the x-axis. And then finally P and S on the y-axis. Alright, so now that we have written everything down, so now it is time we go to the first question and then answer that question. Now the first question, 1.1, says write down the length of the radius of the center of the circle having center M. Alright, okay, so now here what do we want to calculate? We want to calculate the length of the radius. So now here, let's look into this diagram. Which lines or which coordinates give us a length of a radius? We can see that here NM can give us a radius, and then we can also see that MK can also give us, MB can also give us, and MA can also give us a radius. But now what are we going to do here? So now the one thing that we're going to do here that is important is to look for the one that has more information. Now here, if you remember, we were told that the circle touches here once, right? So if it touches on the y-axis once, and we see that NM here is a radius, we can also see that here this MN and this y-axis acts as a tangent to this circle. So now here, what is going to be the first thing that we're going to say here? We're going to say here, first things first, when we answer, we're going to say NM, it is perpendicular to what? To the y-axis. So what could be the reason for that? Radius perpendicular to tangent, right? then after that, what are we going to do? So if that's the case, this then means now if mn is perpendicular to the y-axis, it basically means that nm, right, is parallel to the x-axis. And if mn is parallel to the x-axis, let me just rewrite this, parallel to the x-axis. Now if it is parallel to the x-axis, it then means now to calculate the length of nm, we can see that the point of n and m, they have the same y value, but they differ in x values, right? So it means now if I want to calculate the length of nm, I'm going to take the x that is at the right, and then I'm going to subtract it with the x that is at the left. Now here the x that is at the right is going to be the x coordinate of m, as you can see, and the x that is going in the left is going to be the x coordinate of n. So let's go ahead and do that. So now nm, which is the radius, is going to be xm, which is the x coordinate in the right, minus xn. So what is xm? Xm is 5. What is xn? If you remember previously, we said that n was the y-intercept. It means its x value is going to be 0, right? So we're going to say 0, and therefore 5 minus 0 gives us 5 units. And therefore this is our radius. I hope this makes sense. I tried to explain it. Now I hope this makes sense. Now let's go ahead and look into the second one. Now the second one, 1.2, says write down the equation of the circle having center M in the form of that. Now first things first, let's talk about the form, right? The form x minus a squared plus y minus b squared equals to r squared. So how does this form work here? So here the coordinates a is to b, they act as the center of the circle, right? Or the coordinates of the center of the circle. And then here r, x is a radius, right? Now here we see that already we have what? We already have the center. Now what is the center? The center, it is 5 is to 4, right? And what about the radius? The radius, it is 5 units because it is mn. So this then means if you substitute these values here, you can see that a is 5 and then b, it is 4. So let's go ahead and substitute there. Therefore we're going to say x minus, then in the place of a we're going to put in 5 squared plus y minus, then I'm going to plug in 4 squared equals to, now 5, r is 5, so 5 squared is what? It is 25. And that is going to be our final answer. Now let's go ahead and look into the next question. Now 1.3 says, now let's calculate the coordinates of a. So now we do have the equation now, right? If you remember, we got the equation of the circle now, which is x minus 5 squared plus y minus 4 squared equals to 25, right? So now we want to calculate the coordinates of a. If you remember, a, we said it was an x-intercept. So now in x-intercept, right, we always let y to be 0, right? So let's go ahead and do that. So we're going to have x minus 5 squared plus 0 minus 4 squared equals to 25. And now if you're simplifying here, I'm going to have x squared minus 10x plus 25, and then press 0 minus 4 all squared in the calculator gives you 16. Then we're going to get 25. Then we're going to take the 25 over. So when we take the 25 over, it's going to subtract with this 25. So these ones, they're going to cancel out. And then you're going to be left with x squared minus 10x plus 16 equals to 0. So let's factorize here. So if you're factorizing here, I'm gonna get I'm gonna get 8 and 2, then minus minus, which means x is going to be 8 or x is going to be 2. Now looking into this diagram, you can see that here the x coordinate of A needs to be smaller than the x coordinate of B. So this then means now our final answer here, the x coordinate of B, our final answer here, the coordinate of A is going to be 2, 0, and that is going to be our answer. Now let's go ahead and look into the next one. Now 1.4 says if the coordinates of B are 8 is to 0, let's calculate the gradient of MB. Alright. Now we're looking at 1.4. 1.4. So let's go ahead and look into 1.4 again. So in 1.4 we're told that B is 8 is to 0, and then now the question says let's calculate the gradient of MB. Now we know that the gradient of MB is what? It is y2 minus y1 x2 minus x1. So let's write the coordinates here. We know that M is 5 is to 4, and now we know B it is 8 is to 0. So now if we simplify this, it's going to be 0 minus 4 over 8 minus 5. If you press it on your calculator, you're going to get minus 4 over 3, which is going to be the gradient of MB. Now let's look into the next one, which is 1.4.2. Now 1.4.2 says let's determine the equation of the tangent PB in the form of y is equals to mx plus c. Alright, now here we got the gradient of this line, right? So now we want to calculate the gradient of this one here. So how are we going to do this? So we can see here that MB is a radius, right? And then PBL is a tangent. So a radius, we know that it is always perpendicular to a tangent, but now we need to state that first. Alright, so now here we're going to first say MB, it is perpendicular to PBL, and then the reason for that is going to be radius perpendicular to a tangent. So because of that, it then means now the gradient of PB is going to be a negative reciprocal of the gradient of MB, which means it's going to be 3 over 4. So where do I get this 3 over 4? You get it from the idea that if I have two lines that are perpendicular to each other, then it means the gradient of one line, so let's call it MB, if you multiply it with the gradient of the second line, which is PB, the answer you're going to get is going to be minus 1. So that's how I got this value here. So if here my gradient was minus 4 over 3, it means now here I need to have a negative reciprocal to make minus 1. So here I got minus, so it means here it needs to be positive. And then I just swap the fraction there, right? Just like that. Okay, so now that I have my gradient, then it means my equation now is going to be y is equals to 3 over 4x plus c. So now what do I need now? I need a point, right? So the point, I already have the point, I have b, so I'm going to use b. So we're going to use b, which is 8 is to 0. So doing that, it gives us 0 equals to 3 over 4 into 8 plus c, which is 0 is equals to 6 plus c, and therefore c is equals to minus 6. And so the equation becomes y equals to 3 over 4x minus 6, and that is how we got our answer. Now let's go ahead and look into the next question. Now question 1.5 says write down the equation of the tangent SKL, right? Okay, so we want to have the equation of SKL. So let me just run 1.5 here. So now let's have a look at SKL. So what do we have about SKL? Remember, we were told that SKL was parallel to the x-axis. So if SKL is parallel to to the x-axis. Let me just write this: SKL parallel to the x-axis. What does this mean? So it means that this equation SKL, all the points, the point of S and the point of S and the point of K and the point of L, they're gonna share the same y value. So what does this mean? So this means the y value of S is gonna be the same as the y value of K, which is gonna be the same as the y value of L, right? So this then means now we need to find what is the y value of what? Of L. So to do that, the first thing that I'm going to do is this. I know that this is a tangent, right? So the first thing that I'm going to do is I'm going to say MK is perpendicular to SKL. And then I still write the same reason. I know that my radius is perpendicular to tangent. Now, if this is my radius and this line was parallel to the x-axis, then it means MK is going to be parallel to the y-axis, right? So what am I saying here? I'm saying if SKL is parallel to the x-axis, then MK is going to be parallel to what? To the y-axis. So why am I doing this? I'm doing this so that you can see that if this line MK, it is parallel to the y-axis, it means it's going to be a vertical distance. Now a vertical distance, it means now the point of K, the x-coordinate of K and the x-coordinate of M are going to be the same. So this then automatically means now the x-coordinate of K is the same as the x-coordinate of M. Alright, so now what am I going to do with this? So now this means now what I'm going to do now, I'm going to say therefore the x-coordinate of K is going to be 5. So I'm using this x-coordinate of K, I'm equating it with the x-coordinate of M so that I can take this equation, this x value, and put it on my equation of the circle so that I can find the y value. And if I got the y value, it means it's going to be the equation of SKL. So let me write this: squared is equals to 25. Then now substituting there, when I get 5 minus 5 squared plus y minus 4 squared equals to 25. So this is going to be y squared minus 8y plus 16 equals to 25. Y squared minus 8y. Then I'm going to take 25 over, which is going to give me minus 9 equals to 0. And so if I work out my factorization here, I'm going to get 1 and 9, which is going to be minus and plus, and so y is going to be minus 1, or y is going to be 9. And as you can see here, the y value for K is going to be 9, which then means now the equation of SKL is going to be y is equals to 9. I hope this makes sense. Now let's go ahead and look into the second question. The second question now, it says now show that L is the point 20:9. Now to show that L is the point 20:9, remember L, there is L. Remember these points, all of these points here, the y value of S, then the y value of K, and the y value of L, they share the same y value. But now since the equation here is not written in x, we can't find the x value of L with this equation of SKL, but we can use the equation of PBL to calculate that. So how are we going to use this? So this is how. Now first things first, we know that 1.6. So first things first, we know that the y value of L is the same as the y value of K, right? So it means it is 9. So we have the y value of L as 9, and now we can see that L is the point of intersection of SKL and ML and PBL, right? So now because of that, it then means now we can find that x-coordinate of L using the equation of PBL. So now the question is, what was the equation of PBL? The equation of PBL was y is equals to 3 over 4 x minus 6, right? If you remember, let me just fix this. Y equals to 3 over 4x minus 6. So we're going to use that. Y equals to 3 over 4x minus 6. So what we're going to do, we're going to take this value and then substitute it there. This y value is substituted in the equation, and then solve the x value and see if we're going to get 20. So therefore, I'm going to use YL equals to 9. So let's go ahead. It's going to be 9 equals to 3 over 4x minus 6. Move the 6 over, add it with the 9, gives you 15. It's equals to 3 over 4x. I'm going to take the 4, multiply with 15. That gives you 60. Now 60 is going to be 3x divided by 3 divided by 3, and therefore x is going to be 20. Hence now L is 20 is to 9. I hope this makes sense. Now let's go ahead and look into the next question. Now the next question, 1.7, says calculate the length of ML in set form. Now what do we have here? We have M 5:4, and we have L 20:9. So now we're going to use the distance formula. So ML is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so let's substitute here. So it's going to be 20 minus 5 squared plus 9 minus 4 squared. Now when you press this on your calculator, you're going to get an answer of 5 root 10. Alright, now let's look into the last question. Now the last question says determine the equation of a circle passing through K, L, and M in the form of that. Now okay, now what is happening here? Now here they're saying that here we have a circle, and this circle is touching through M. So let's go and touch through M, and then make the circle and touch through L, and then also touch through K, like that. Now they want us to calculate the equation of this circle. Now before that, we can see that here, if you remember, we were told that MK is a radius, right, on this circle here, this circle that we had earlier. But now here, if you can see, this was the radius. So if you can join that, you will notice that here we know that MK was perpendicular to SKL, right? So this then means now in 1.8, the first thing that you see here is if we join MK, right, such that MK stays perpendicular to SKL, you see that MKL is what? Is 90 degrees, right? So therefore this means now ML is what? ML is a diameter. So why is it diameter? So if you remember the theorem, angle and the semicircle. So the angle in the semicircle, it means that if you have a triangle, right, within a circle that touches its vertex that touch onto a circle, and then that triangle is a right angle triangle, then it means its hypotenuse is going to be a diameter, right? So this then means if ML is a diameter, then now if we want to calculate the radius, so to calculate the radius, we're going to take our diameter, which is 5 root 10, and then we're going to divide that by 2. Now what about the center of a circle? Now the center of a circle, what we're going to do here, we have a point of M, which is 5:4, and the point of L, which is 20:9. So what we're going to do here now, to calculate the center of a circle, we're going to calculate what you call the midpoint. Now the midpoint of ML is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So let's go ahead and substitute there. It's going to be 5 plus 20 over 2 is to 4 plus 9 over 2, and this gives us 25 over 2 is to 13 over 2. And that is all for today's session, and that's all I got for you today. If you like the video, please make sure that you like it and share it to your friends so that they will also see this type of question and understand how they can interpret questions like this. And also don't forget to subscribe so that you won't miss when our videos gets uploaded. And I'm gonna see you until the next session when we will be talking about trigonometry. See you there. Cheers.